In today's lesson, we're going to be looking at a new topic called trigonometry, which is the study of right triangle relationships. And with this, we need to consider three functions or three ratios that we're going to be studying. And these basically just relate the different sides of a right triangle compared to the angle that we're referencing. Now, as we're going through these problems, you might see us use some different variables besides just an X or a Y. And we actually have a tendency to use some Greek letters when we're looking at trigonometry and any higher mathematics. So if you ever take physics, again, you're going to see more of these variables being used. We already use the variable pi when we're thinking about the number 3.14159 when we're thinking about circles. And so you may see like the variables that we have over on the side here. Some of these Greek letters, theta, alpha, beta, or phi, depending on how you pronounce it. But these are just variables and they stand for the angle that we were looking for. And we like to use the different variables so we can kind of keep track of, are we looking at the angle measure or are we looking at one of the side measures? Sometimes problems are still going to use X and Y. It really depends on what the diagram was drawn with. Alrighty, so there are three functions or three ratios that we're going to be looking at. The sine ratio, the cosine ratio, and the tangent ratio. And these are all related to the sides of a triangle. And so we'll look at where those sides are in a second. But right now, let's think about what the arrangement of these functions are and where we would have to plug information in. So as we're looking at a triangle, and keep in mind, we're thinking in terms of where the pieces are compared to the angle that we're referencing. We would want to think in terms of, well, sine of theta, sine of an angle, is always going to be a side that's opposite that angle compared to the hypotenuse. And so in any right triangle, again, we always have the hypotenuse and we have the two legs. And so we can write this relationship as this will always be what's happening in this triangle. We might abbreviate the sine relationship as SIN equals the opposite side over the hypotenuse. And if you look at a scientific calculator or even a Desmos calculator, so you'll see over on the right, I have a scientific calculator, which we'll embed in our practices that you have access to. And we even have that SIN button, which stands for sine. Okay, our cosine function or cosine ratio relates the side that's adjacent to the angle we're using compared to the hypotenuse. And we can abbreviate that as cos theta equals adjacent or ADJ over HYP for hypotenuse. And our tangent ratio takes the side that's opposite from angle theta compared to the side that's adjacent to angle theta. And we can abbreviate that as tan theta equals opposite over adjacent. Now, again, this is going to make a lot more sense if we start actually looking at this in terms of a right triangle. So in example 1, you'll see that we're going to write all three of these ratios depending on which angle we have that we're using. And in any of these problems, we are never going to be using the right angle that's in our figure. We are always going to be relating this to one of the acute angles that's in our right triangle. So let's write out the ratios for sine A, cosine A, and tangent A first, and let's see what those are. And so we need to be able to figure out what's our opposite side, what's our adjacent side, what's our hypotenuse. And so the first thing that I like to do is always identify which one's which. So if we're going to deal with our A angle compared to our A angle, we would need to know, according to our rule, the opposite side and the hypotenuse. Well, the opposite side directly opposite from that triangle, same sort of thing we did when we were relating like biggest side to smallest side, those comparisons. So compared to angle A, this side is our opposite side. And we're actually going to label this as side A. And a lot of times when you're labeling triangles, you might see this in some diagrams that we use. If you have an uppercase letter for the vertex, the opposite side, we label it as a lowercase letter, in this case, lowercase a. So our opposite side, segment BC, or we call this segment little a. And then our hypotenuse is always going to be directly opposite from the right angle. So this is our hypotenuse. We're going to call that side C, little c, because it's directly opposite from the little c. Alrighty, so sine of angle A is our opposite side, which is A, over our hypotenuse, which is C. Our cosine ratio uses adjacent. So the only other side we don't have labeled, that's our adjacent. So adjacent will be this side right next to the A. It's actually touching the A, and it's not the hypotenuse. Because it's directly opposite from angle B or vertex B, we're going to call this little b for our label. And so our cosine of angle A is our adjacent side, B, over our hypotenuse. Tangent always refers to the opposite side over the adjacent side. Well, opposite from angle A is little a side and little b side. Alrighty, so if we change our angle, we have to change our perspective. So now it wants us to go and look for our sine of angle B, cosine of angle B, and tangent of angle B. And so now if we're looking at angle B, let's change our perspective. So I'm going to label all of this in blue. If we're looking now at angle B, well, now our labels change. The side directly opposite from angle B is little b side. So let's go ahead and label this as opposite. Let me rewrite that. OPP. So compared to angle B, side B is opposite. That would make side A now our adjacent side. Our hypotenuse is never going to change. Hypotenuse is always directly across from the right angle every single time. So to write these ratios out, sine of angle B is the opposite side, which is little b, over the hypotenuse, which is C. Cosine of angle B, again, adjacent side, which compared to B, that's side A, little a, and hypotenuse. Tangent is our opposite side over adjacent side. So opposite compared to angle B is little b. Adjacent compared to angle B is little a. The more we practice this, the more these ratios will start sticking in your memory. But one of the ways that we can remember it is kind of by mnemonic or rhymes. And one of the things that you'll see a lot with trig is the phrase SOHCAHTOA. And there's a few different ways that you can help yourself remember these. This really is just the first letters of all of our representations. So our sine is the opposite over the hypotenuse. Our cosine is the adjacent over hypotenuse. Tangent is opposite over adjacent. And so when I write this out with the letters, I find that if I write it going up to down, it definitely gives me the order of the fractions that I'm going to use. If you have any difficulties remembering the order, there's a few different ways to do this. Listen carefully, because this will be the only time that I say this. Some old hippie came a hopping, tripping on acid. That's the way I learned it in high school. Another way that we might say this would be some old horses chew apples happily throughout old age. Whatever you need to do to remember that order, if that helps you figure out your relationships, use it. That being said, these are written on our SOL formula sheet, and they will be provided for you on your test. The more you can do to kind of help yourself remember, though, means you'll save yourself a little bit of time in the long run. So now let's look at an example where we have number values labeling the sides of our triangles and see what sort of relationships come out of that. So let's start with angle A. And so I like to identify that on my diagram. And again, let's label what pieces are what. So I know the side that's opposite the angle A, that's going to be 30. I like to label the hypotenuse next if I have it. That's always directly across from the right angle. So 34 is my hypotenuse. And my leftover is going to be my adjacent side. And again, each time I'm picking out which angle I'm using, I'm always going to redo my labels to make sure that those are accurate. So number 2, sine of angle A, if that's opposite over hypotenuse, opposite is 30, hypotenuse is 34. And then I can reduce that fraction. Both of those numbers are divisible by 2. So that's really 15 over 17. Okay, cosine of angle A means I have to do the ratio adjacent over hypotenuse. Adjacent side is 16. Hypotenuse is 34. Same thing. Both are divisible by 2. So divide that out and I get an 8 over 17. Tangent of angle A is opposite over adjacent. Opposite side is 30. Adjacent side is 16. Reduce those down, we have 15 over 8. And so our next three are dealing with a different angle. So I'm going to redo my label. So actually, let's go ahead and erase things out. I'm going to change my color and now relabel according to angle B. And so if you're writing in pen, try redrawing the triangle with your new labels. So according to angle B now, opposite side is going to be the 16. 34 is still the hypotenuse. And 30 is now the adjacent side to angle B. And so this changes up our ratios. Sine of angle B is now going to be 16 over 34, which reduces down to 8 over 17. Wait a second. We already had that answer for cosine of angle A, didn't we? The cosine of B, adjacent over hypotenuse. Well, wait a second. The same thing's happening. Reduce it down, 15 over 17. But that's the same value as what we had for sine of A. Okay. Tangent of angle B, opposite over adjacent. Reduce it down, gives us 8 over 15. Hey, related to the other tangent because they're reciprocals of each other. And this is going to happen every single time. If you write all the ratios for the entire triangle, you're going to have these repeats in here because you're using all the same sides. All you're doing is changing your perspective on the problem. And so that's why the fractions are flipping over from each other. Another piece that kind of goes along with this is if we are then looking at what kind of values we get out for each item, well, these are always going to be reciprocals or always relating to the other angle that's in that triangle. So because your angles in a triangle are always going to add to what value? Now, all angles always add up to 180 degrees. What's going to happen is your two acute angles of that right triangle, since those are always going to be, reciprocals of each other if we look at our trig ratios, well, the values that we'll get out from that will also be related. Specifically, they are going to be complementary. And there we go. So no matter how I set this triangle up, if I named it triangle ABC, if angle C is 90 degrees, then no matter what, angle A plus angle B is going to be 90 degrees. And we can also translate that over to looking at our sine and our cosine values as well. So our complementary value is always going to be that other sine or cosine. So for example, if we have the sine of 30 degrees, well, in a right triangle, what would be that other acute angle? Well, they're always going to be complementary to each other. So the complementary angle is going to be 60, right? Because 30 degrees plus 60 degrees equals that 90 degrees that they should have. And so the sine of 30 degrees will always equal cosine of 60 degrees. And again, if you don't believe me, when you look at a diagram, try writing that other ratio. And once we learn how to plug that in the calculator, you'll be able to prove it. Okay, cosine of 62 degrees. Well, that's going to equal sine of, well, what value adds up with 62 to make 90? Well, 62 degrees plus 28 degrees will give us that 90. So cosine of 62 equals the sine of 28 degrees. Okay, sine of 80 degrees. What do I add to 80 to turn it into 90? 80 plus 10 would give us 90. And so the sine of 80 degrees will equal the cosine of 10 degrees. And so let's test that out on a calculator, see if that actually works. And so here's where we need to start talking about how you can use your calculator to solve these problems out. And today, all we're going to look at is how to solve out for angles when we write this equation. Next lesson, we'll look at how to solve for sides. So when you're looking at your calculator, and I don't care if you're using a TI calculator, the Desmos graphing calculator, or this standards of learning, the scientific calculator, which we'll embed in our test, you do want to double check to make sure that you have degrees as your mode. It's kind of like using inches versus centimeters. We have different units that we use for measures. When we're dealing with angles, the two different kinds of measures we could have, or two kinds of units we could have, are degrees and radians. And for all of our calculations this year, we're always going to use degrees. In future classes, you might use radians. And so on the scientific calculator, the way that we toggle that off is we know that we have this toggle switch right in the middle. Notice how it says RAD, that stands for radians, the other unit measures that we don't want to use. We want to hit that button and it'll toggle over until it says DEG for degree. And so that means we are now in the correct mode and we can start plugging things in our calculator. So let's test out those three statements that we just made. So statement or problem number 8 said sine of 30 degrees equals cosine of 60. So this is what happens when I try typing in sine of 30. So sine 30. And it spits out a number answer. Notice it is putting parentheses around the 30, which is fine. And so a lot of times you'll see parentheses around that value. Okay, so let's check the next one. So let's see here. That's supposed to equal cosine of 60. So cos, I don't know why this keeps pulling up. Sorry about that. Of 60. It came out to exactly the same value when we wrote that up. Awesome. Let's check the next one. So let's clear everything out. Okay, let's try number 9, cos 62. Okay, so cos 62. There we go. 0.49874, et cetera, et cetera. So that should be equal to sine 28. There we go, exactly the same value out. Okay, so how can we use this to solve for missing information in one of our triangles? So here's what we're going to do. Okay, let's go back over here. Okay, so when we are solving for things in a right triangle, we always want to first double check we're in degree mode. So we just did that. And so let's see how we would use our ratios to set up these problems. So the first thing that we're going to solve for is x. Now, I know I said sometimes we'll use, variables like x and y. Sometimes we'll use like that theta. It's just a placeholder to say this is the piece that we're looking for right now. So let's start out by solving for x. So solving for x, we're going to write our ratio depending on what sides we have. So compared to our x, the 3 is our opposite side and the 4 is our hypotenuse. So what ratio do we know that uses opposite and hypotenuse? Well, that's our sine ratio. So that's the equation I'm going to write. So sine of angle x equals opposite over hypotenuse, or 3 over 4. And so the way that we're going to solve this problem out is you'll notice x is inside the parentheses, it's with that sign. We need to the calculator to say, hey, look up what angle I would have to plug in to make this statement true. And so what we do to solve that is we're actually going to plug in something a little different. We're going to plug in sine inverse of 3/4, and that will spit out our answer for x. Alrighty, so well, how do we get to that? So on our scientific calculator, you can hit the FUNC function, and when you hit that button, you'll notice you get a new set of buttons that pop up. We've got sine inverse now sitting right there, so hit sine inverse. Again, still showing the parentheses with here's what I need to plug in. And so go back over to main and type in 3 divided by 4. And it spits out what our angle measure should be, which is 48.5903778. So our x, our angle, is approximately equal to 48.590. I'm going to round up to 4. Now, a lot of times when I'm writing out these angles, I will write it out to 4 decimal places, because when me and Ms. Milligan or any of your math teachers have learned how to do trigonometric ratios and solve these problems, instead of having a scientific calculator, we always had to look these up on tables and just printed out tables, and they always had things out to 4 decimal places. So that's what has typically become the norm for these problems. Some problems will ask you to round to the nearest 10th, some will ask you to round to the nearest 100th, and some will ask you to round to the nearest 10,000th position. Again, don't forget 10,000. That number has 4 zeros, so 4 places in there. That's why that gets used in a lot of situations. Alrighty. So next piece we're going to look at is, well, now let's solve for the y. So I'm going to actually, let's change our labels. So I'm going to delete those extra labels because now we have to change our perspective and look at our y value, our y angle. So let me change my color to red. We are now going to solve for y. So y is what we're solving for. Compared to y, we have our adjacent side and we have our hypotenuse. So what uses adjacent and hypotenuse? Well, that's cosine. So cosine of angle y equals adjacent over hypotenuse. Again, it's okay that we have the same fraction coming out because we're looking at a different angle and taking a different perspective, we're going to get a different answer out. So again, to plug this in the calculator and get out an answer, I will have to plug in cos inverse or cos to the -1 of 3/4 equals my angle y. So going over to my scientific calculator, again, to get to those extra functions, I hit the FUNC for function, look at cos to the -1, and then plug in my angle or plug in my ratio. So back to main, 3 divided by 4. And I get out that my y angle is approximately equal to 41.4962 degrees. And actually, I should have degrees on my first answer as well. Degrees. So if those are our 2 angles in the right triangle, again, these should be complementary to each other. So let's double check that. So let's see here. We've got 40, oops, excuse me. Let's go to our next line. So 48.5904 plus 41.4962. And we're getting pretty darn close to 90 degrees. Again, we did round off on our answer, so that's why it's not perfect, but that is pretty darn close to 90, so I know I had the correct answers. So let's just look at a couple more practice problems. So 2 more that we'll do together, and then I'll leave the last 3 for you to check out, but they will absolutely be filled in on our completed organizer for you to check your work. Alrighty, here we go. So example 12, we have our angle x, only angle that we're trying to solve for. So label your sides. Compared to the x, 4 is our opposite and 1 is our adjacent. So that means opposite and adjacent uses which rule? Well, that's tangent. So tangent of angle x, again, just as a reminder, that's going to be our opposite over adjacent. And so then we fill in the info that we know. So tan of x equals opposite is 4, adjacent is 1. So to plug this in the calculator, we're going to do tan inverse 4/1, and that will look up the answer for us for our x. So let's go over to our calculator and plug that in. So function tan to the -1, and we plug in the fraction 4, or technically I could just leave it as 4 because 4 divided by 1 is just 4. And there's our answer. So we get approximately 75.963 degrees. Alrighty, example 13, again, we're solving for x. Compared to angle x, 12 is what kind of side? That's our opposite. 16, directly across from the right angle, is the hypotenuse. So we're going to use sine of angle x equals opposite over hypotenuse. And again, you don't always have to write this first step. So a lot of times I will go ahead and just write out my equation with my values, 12/16. We could reduce the fraction on here, but the calculator will still calculate it for us no matter whether we simplify it or not. So I'm just going to leave it as is. So sine inverse of 12 over 16, again, we're telling the computer, go backwards. Say, look up the answer for 12 over 16. If that was the sine, then what is our angle measurement? And so x will be approximately, again, go over to your calculator, function, sine inverse, back to main, and type in 12 divided by 16. And our solution comes out to be approximately 48.5904 degrees. If you ever get error messages for these or for the problems that we're going to do next class, again, big things that you want to check. Make sure you put your calculator in degree mode. Double check that you used this inverse when you're solving for an angle. And if you did both of these, go back and double check your labels on your triangle. Make sure that you're using the correct opposite side or correct adjacent side or correct hypotenuse. Again, I'll leave the last 3 examples for you to try out on your own, but try those out and then check the completed organizer to see how you did. Let us know if you have any questions at all, and we will continue practicing this tomorrow.